But I think, given our time constraints, we'll just dive right in here. Just some quick introductions. My name is Ben Gannon. I think I know everybody. I work with the county's Department of the Environment. We've got Tim Koch from Cornell Cooperative who'll be going over some slides. He's the one that developed the assessment protocol that we used. We have Jim and Scott from the Hudson River Estuary Program, who are our funders, partnering with NUIPIC on this grant. I see Lou from the town of Marbletown. We do have a phone number, so I'm not sure who that is. But welcome. As I mentioned, this is going to be recorded. I'll cut out the beginning stuff. So if you're watching this in the future, welcome. And then we've got somebody from the city of Kingston just joining here. So this will be pretty quick. We're gonna go. I'll give just a quick project overview. Tim will dive into the assessment protocol that we've been using. We'll talk a little bit about how we prioritize and score crossings, and then really we'll spend maybe about half of the time just showing you the web tool that we've developed as part of this project. Does anybody have any questions before we jump in? All right, feel free to raise your hand or jump in verbally or jump in the chat. It's a pretty small group, so totally welcome discussion and questions throughout. All right, so let's dive in here. So we've been working on this project for a little while now. We received a grant from NUIPIC and the Estuary Program, like I mentioned. And really the goal here is to finish assessing road stream crossings town-wide for all of the lower Esopus municipalities. We completed Woodstock, Saugerties, and the town of Kingston in a previous grant a few years ago. The second main big piece of this project here is that we are working on conceptual designs, and so we worked with the municipalities to prioritize sites in the beginning, and then we're working with Collier's engineering on conceptual designs, which I'm expecting those maybe today or tomorrow, hopefully, and I'll share those as soon as I get those. We're just waiting on updated cost estimates from the engineers, and then kind of pulling everything together and getting all the information that we've collected online. And the goal here is just to develop a really easy to use dashboard that you can quickly see which road stream crossings are prioritized and for what reasons. As part of this, we hired a field team that worked throughout the summer and fall assessing the crossings. So you may have seen them out there. And we used this protocol. And here I'll turn it over to Tim to give everybody an intro to MOSCAP.
Sure, thanks, Ben. Yeah, so the MOSCAP, Multi-Objective Stream Crossing Assessment Protocol, was something that we developed in the Upper Esopus, the Shokan Reservoir watershed back in 2018. When I came on board to the program with Cornell Cooperative Extension of Ulster County, one of my first tasks was a culvert assessment, and I had some experience with NAC, which we'll get into a little bit later, and found that it was not quite as comprehensive as we needed. So we developed this MOSCAP, which we'll get into. So you can go to the next slide, Ben. So these are some old slides from a different presentation, but it's another way to inventory road stream crossings. And the idea is still to have it be a rapid field assessment. So this is not an engineer's assessment or anything like that, but it is meant to be a little bit more comprehensive. I didn't reinvent the wheel. Basically, what I did was went out and found these 4 existing protocols, combined them into this sort of streamlined field process, and then developed a scoring and prioritization system that Ben will touch on a little bit later to figure out, and it's customizable. So depending on what the stakeholder priorities are, you can weight things differently to get different crossings to float up to the top of the list. Next slide. So one of the four components is this flood flow capacity. This uses the Cornell Culverts model, which is a GIS and Python-based hydrology and hydraulics model. Uh, it's very clunky. It's very hard to use. Uh, it is doubly conservative, and that has been confirmed by a recent research project we did in the Upper Esopus again. So doubly conservative in that it tends to overestimate the hydrology and underestimate the capacity. So it's just something to keep in mind. But it's sort of the best option out there, other than hiring an engineer to run HRAS, or perhaps I know folks like the county can use HY8, but for a field crew or someone like Ben and myself that might not have that technical capacity, this is a decent stand-in. Oh, and I should mention too, for the flood flow capacity, the constraints of the model. This will not model every crossing. It doesn't do bridges. That should be a whole different hydraulic model. So this model is limited to actual culverts, round, elliptical, open bottom, and box bridges up to a width of 20 feet. Those are the only structures this will model. Next slide. So this is the real important one that I think, this geomorphic compatibility, and it's kind of looking geomorphic indicators in the stream and trying to determine whether the structure is influencing or worse, interfering with natural stream processes. So things like, flooding, is it allowing any sort of flood flow through these structures, sediment transport. So some of the things that we look for in the field are signs of bank erosion, scour in the bed or underneath the structure, upstream deposition and the types, which can give you a little bit of an idea of what's going on hydraulically, sediment and debris continuity, and both the presence and the condition of any bank armoring. Again, this isn't something I came up with. This is pulled from the Vermont Stream Geomorphic Assessment, Appendix G, which you can see there. The only modification I did make to this was we were looking for bankful widths. Bankful indicators can be very, very hard to determine. Even in alluvial settings, you get into these highly modified settings, they can be nearly impossible to find. So we switched bankful for what we were calling active channel. Perhaps a bit semantics depending on who you're talking to, but more the point being, it's wider than the wetted. We were looking for things like scour lines on the banks, flattened vegetation, depositional features. I just wanted to point out that we were not claiming to be measuring actual bankful width. So that's geomorphic compatibility. The next slide. This is another really important one, and this was what I found NAC to be very lacking in. NAC has recently come out with a structural condition assessment, but I still prefer this one, which is pulled almost word for word from the New York State Department of Transportation Culvert assessment method. The DOT method has a lot more components, but I pulled out the 7 kind of main structural components. So pavement, differential settlement, embankment, span barrel abutment, head wall, wing wall. Not every component is present at every structure, so we finangled the scoring so that if there was no head wall and wing wall, it calculated the score for the components that are present. It's ranked from 1 to 7. So if it's brand spanking new, the pavement's going to be rated a 7. The photo here is a failed wing wall, so that was rated a 1. And actually, if you look up in the top right of that photo, you'll see that failed wing wall has actually created a slumping in the embankment. So this was I don't remember the exact scoring, but probably a 2 or 3 for the embankment there, because it was threatening the road surface up at the top. Next slide. The last one, which probably some of us are more familiar with, is this North Atlantic Aquatic Connectivity Collaborative, or NAC protocol. And this is really ecologically focused, looking at aquatic organism passage. So it's got a couple of the key features that determine this are outlet drop, whether there's a vertical drop at the outlet of the structure, excessive velocities, a lack of water depth a lot of times in these structures, you get very, very shallow sheet flow, as well as a lack of substrate, which is going to hinder aquatic organism passage through the structure. So I believe maybe Ben's now going to touch on how those four kind of get molded into a unified prioritization strategy.
Yeah,
Correct me
great.
if I'm wrong.
Yeah, no, thanks, Tim. The reason why we've been using this protocol that Tim's developed is that it's just a lot more comprehensive than kind of the industry standard assessment protocol, which is NAC. And like Tim mentioned, it really focuses on the aquatic connectivity piece. But we realized that there's a little bit of a gap in there that, there are other factors that drive considerations when, we're looking at replacing crossings. And so that's when we really started to look into the structural piece and the geomorphic piece for what is the stream doing? For example, erosion right at the structure can cause major road issues. And then this flood flow capacity input is really getting at what's severely undersized, and it's a model, so it'll tell us what it thinks floods regularly. But when we put everything together, we kind of get this overall ranking score, and then we can couple that with the local experience and the knowledge of the highway staff or town staff, to just make a better judgment call on where the priorities are. And so I just want to address that. Everybody on this call, you should know that, we had a field team out assessing. And so I would say that the structures evaluated and the rankings that come out of that are comparable to the area, but, we're not intending to tell you what the priorities are. This is just from the assessment data. Here's what's floating to the top. And then really, depend on the local knowledge to validate our results, when you're putting together plans for replacement or applications for funding. So really the goal was just to create a tool to, rapidly assess structures to see what comes out on top. And honestly, one of the more helpful pieces of this is that in the NAC assessment, there are links to each assessment record for the crossing, and there are photos that we have to take at each crossing, which, in my experience and working with highway superintendents in our area, the photos are a really important piece because, we're inside the structure, we're taking photos of anything that is, severely damaged or out of the ordinary, as well as the inlet and the outlet and the pavement condition. So it's just an easy way to look at all of the structures in your town, that we've assessed at least. So I think I've got one last kind of thank you slide before I jump over to the website, and I can come back to this at the end if folks need our contact info. But with that, I can pause and see if anybody has questions before we get into the website.
Can I ask a quick question?
Sure, go ahead, Scott.
So I figured everyone likes a question,
Yeah.
So Tim, you referred to the fluvial assessment, and I'm just wondering if you could speak to the application of that when you're trying to identify priority projects, or how that fits into the rubric of on your end, and how does that add value to your kind of prioritization? Is it the available funding? Is it the sediment contribution reduction? Like, how does that fit in?
Yeah, good question. It can fit in a lot of ways, and kind of like Ben said, more often than not, we'll do this whole assessment, and we've done like 2,000 of these, I think, in Ulster County, getting close to it at this point in the last 6 years. But so we'll provide these data. When a high priority crossing matches up with one from a town, for example, a town will come and say, this is a priority for us. How does it look from the data? And we'll pull it up. And, just by doing that quick desktop analysis and knowing if there's significant sediment deposition on the upstream and being able to compare perhaps erosion upstream and downstream, scour downstream versus deposition upstream. Without even visiting the site, you can start to get a little bit of idea. This isn't really working with the stream. And then when it's not working with the stream, and I have some stats on this that we could look at some point, but those crossings that come up as geomorphically incompatible oftentimes score poorly structurally and as flood flow capacity. So it's a little bit of like validation almost. And it does, as a more specific example, NAC has only 2 alignments, skewed and aligned. The Vermont geomorphic assessment has, I believe, 5. Alignment is a huge factor with crossings, especially when you get to these ones that are more than like 45 degrees. And so it gives you just sort of a better picture of how it all fits together, because really, in my opinion, the geomorphology is really the foundation of it all. So if the geomorphology isn't there, you could put in a new structure, but if it's not addressing some of those geomorphic issues, it's going to deteriorate more rapidly. It's going to be more susceptible to failure, more likely to require repetitive maintenance. So
has there been a specific example where the geomorphic data has actually been kind of the threshold that was needed to do the project or to implement a project? Was it like it was the critical piece of information that added enough value that allowed you to implement a project? Is there an example of that? If not, that's fine too.
In the Upper Esopus, definitely. We've used these to secure funding for a number of projects through the SMIT program. When we run these in the Upper Esopus, we also have a field value for whether or not there's fine sediment present, the custom plays. And so if there is fine sediment present and there's high erosion in the bank, or there's scour present in the bed, that's a validation that this is a real water quality concern, and at least warrants further investigation.
Got it.
So, this was added pretty specifically for that water quality nexus in the Upper Esopus. I can't say in the Lower Esopus, Ben, if that's ever been that threshold tipping point.
Right. Yep. Makes sense. Thank you.
Good question. Thanks.
Yeah, that's a good question. I think for us, so far, because we started this a little later than Tim did in the Upper Esopus, mostly it's more of that validation piece and looking at specific indicators more around the stability of the stream and its location with the structure. All right, great. Thanks, Scott, and thanks, Tim. So this link is included in the agenda, and I'll send it out to everybody after the meeting or maybe tomorrow. But basically what we did is, we had pulled together management plans as part of a previous project, and our goal was to get the management plan in a website form, as well as easy access to the data that we collected. So this is the homepage, just some quick background information. These are the specific data sets. We built the entire thing on ArcGIS Online, and so these are just easily mapped web layers that you can explore independently if you want. So, for example, here are all the NAC assessments for Ulster County. Then these should be regularly updated. Some other related projects that the county's working on. And really the two important things, I'll go to the second menu item here first. This is our management plan. And so we divided it into 3 chapters. One is just a kind of a background. The next one is kind of management practices and how we evaluate crossings. And then chapter 3, how to navigate barriers and really how to move forward with either maintenance or replacement, as well as funding sources. So you can click on each of these chapters and a full narrative will open up. The narratives are navigable, so there's tabs. So here's that overall priority score that we've been talking about, and here's how everything is ranked. So as you scroll through, you'll see kind of those 4 pillar scores that Tim was talking about that make up MOSCAP. So hopefully this structure is helpful for folks. Let's just go back to the management plan for a second. So if anybody has feedback on layout, once you dive into it in everybody's free time, we're definitely looking for feedback on these, and it's something that the county's interested in just keeping up to date over the long haul as we do more assessment work. And so this is really built for the whole county. You're just lucky enough to be the part of the first round of municipalities. So that's our management plan. We coupled that with this dashboard that we've been developing. And I think this is the real foundation for the whole project. And so you can see these are all the assessments that we've done as part of these 2 projects that we've worked on. So we've got the lower Esopus watershed towns pretty well covered. And the reason why this is so helpful is that these are all interactive. And so we can click on different towns and the map views and data filter based on our selections. And so just an overview of how to use this, you can select really in any of the tables on the left. There's a details table at the bottom, as well as kind of this ranking pie chart for your results. So if we want to expand our areas even, this is all interactive. There is a little more information on this little sidebar here, as well as links to more information on NAC and MOSCAP. We were talking about scoring for a little while, and you will see an asterisk up here. And the asterisk just indicates that it was scored, but 1 or more of the 4 data inputs are missing. And so it's just, use the asterisks with a little bit of a caveat that you might have to do some more homework just to understand how it was scored. And like I said, the details table is down here. That includes a link to the NAC survey. And this is where I was telling you about how the photos can just be really helpful. So this is all publicly available data. You can search by the survey ID, or you can search just on the NAC website. It's NAC.org, by your town. So they've got this neat little search function here. So but all of that information we've included on our map. The pop-ups are generated, so you can just kind of scroll around the map and click on different crossings. Here's again the link, just duplicating the link down here. And this really just outlines how the crossing scored. And so these are the 4 main, I guess we have 3 main scoring metrics here. I'll have to add the geomorphic one. Let's see. The other neat thing about this is that we have other layers built into the map. And so we're including different layers pointing to the same data source, just symbolized differently. So if you want to see crossings that are coming out on top just for structural condition, you can turn that layer on. And so here they are, all the same points, just symbolized for structural condition. There's also a disadvantaged communities layer that you can turn on and see where New York State is designated as a disadvantaged community. This is helpful when going after funding applications. Let's see what else we have. The Ulster County Planning Department recently wrapped up a vulnerability study on infrastructure like bridges and roads, and so those layers are on here as well. They're the top 50 most vulnerable bridges and road segments according to that project. There's also the New York State dams layer, and a bunch of other fun data layers that you can just turn on and off by using the layer button. Let's see, am I missing anything? I think that's about it. So this is currently in development. We're almost done with it. We would really welcome feedback. And so, you know, as it gets released and you play around with it and start to look at your town, definitely let us know what feedback you have for us. And you know, I'll happily consider modifications, you know, and if there's something that's really specifically useful for your management or your day-to-day activities, you know, I'm happy to have discussions on that and figure out ways to make this a little better. So with that, I'm happy to take questions, discuss this any further.
It's Andrew Emmerich from DPW. Is there any information on there as far as if somebody's not sure of the authority for ownership of the culvert? Like, or is it just, you know, basically you go weed through it based on what road it's on?
We go based on what road, and I know it gets a little tricky. You know, for example, Andrew, as you know, the county's got some bridges on town roads, and so as far as specifically outlining ownership of a structure, you know, other than the road, I don't think we have anything. But if those data are available, it's something that we can definitely think about getting in here.
I think that could be useful.
It's definitely come up in the past.
Yeah, that was something we really wanted to work in when we first started working on MOSCAP, but as Ben kind of implied, once you start getting out there, at least in a lot of the areas we were in, there was no way to know without contacting both the county and the town specifically, and to do that for hundreds and hundreds of crossings just was too laborious.
Yeah, I know it's something that we worked on a little bit during the last project, just to outline what is county-owned infrastructure, just so we can know quickly what's owned by the county. So yeah, Andrew, maybe I'll follow up with you on that. We could talk about different ways to incorporate that.
Yeah, no, it's definitely it's a lot to take on. I don't think there's too many county culverts on town roads. I know it happens in like on Woodland Valley Road in Shandaken, but for the most part, I think the ownership just goes by the ownership of the road for culverts. There's a lot of bridges that we have that are on town roads, but culvert wise, they basically stick by whoever owns the road.
Yeah, I believe there's road jurisdiction in here, and so again, that just gets
Yeah.
to going based on the road.
So if you clicked on one of those dots, would it tell you what road and whether it's county or town?
So let's see.
Because I personally probably would not know that without, you know, cross-referencing. If you lived in the town, you'd know.
Yeah.
If you worked at the county, you'd know probably.
Yeah. I think the quickest way of doing it based on the road data is that there is this jurisdiction code, and that's lined up to the New York State Department of Transportation codes. And so there's a big table. I think it goes up to 14 or 15 or more. And so what we could do is basically just do a lookup, and put this kind of up here. I think that would probably be the quickest way of doing it. But again, if for example, the county owned a bridge on a town road, you know, we'd have to override it somehow because it would come up as a town owned, just if we went just based on this.
Or you could just put an assumption in there.
Right. Yeah.
I think the good thing is though, if somebody from a highway department or their town is looking at this, they're gonna know which roads are theirs and have this information available to them. So that's a
Yeah.
plus.
Yeah, for sure. And now that we have the pop-up open, I pulled the most important information up to the top, which are kind of those summary scores, but um, feel free to scroll down. These are all the data that we collect in the field. And so this is joined with the NAC data, and then all the MOSCAP data. So you can see what the field crew ranked individual characteristics of the crossing. So here are all the DOT scores. And again, we're not engineers, so but this is all backed up by Tim's field manual with kind of photo references and a pretty experienced and trained field crew. So yeah, a lot of data. Hopefully it's helpful. But like I said, I'm more than willing to consider different aspects to make this better and easier to use for everybody.
Ben, I'll add too, when you had the pop-up open, one thing we added last few years that I've found kind of helpful, especially from the local perspective, is there is a stream order field. I've found that there's kind of this sweet spot in like the second and third order streams. Once you start getting into fourth order, they're going to be these big bridges. And the first order, a lot of times it's, they're replaced with whatever is available in the yard. So when you're really trying to target good projects to go to design, that I've found personally that second and third order is a nice spot. So if you're poking around, you can get an idea for the size of the stream.
Yeah, I have some of those, but I can work to update those as well.
The other one you had pulled up before I had it. So.
I should have kept it open. So does anybody have any more questions? All right, so as far as the project goes, like I said, I'll work to get you the designs as they come in. And then one of the last pieces is just getting the Cornell model results on here. And those exist for a large portion of the county, as well as doing just some final tweaking to the scoring to show some more data. But like Tim mentioned, and it's something that I was interested in asking everybody the 4 pieces of MOSCAP are weighted, and that is what gives us the overall priority ranking. And so there is a kind of a default current ranking in here, but this is easily changed based on what people think are more important versus less important. And that's an easy change on my end. If anybody has strong feelings on weighting one of these more than the other, and I know kind of weighting suitability is a kind of a deep science, but I think if we can come to consensus on different weights, or if anybody has strong feelings on weighting one parameter over another one, I'm happy to have that discussion.
Well, I would just say, out the gate that, our program is, I would say, primarily focused on aquatic connectivity as the primary. Everything else contributes to that. Capacity, structural, whatever else. I can't really read it, but
Yeah.
Geomorphic, is it a structural geomorphic?
Modeled flood flow and aquatic passage.
Yeah. So we would want, for us to support an implementation project or a design project, we would want aquatic passage to come out high, as opposed to, say, structural integrity. We care about that, but we're not a structural integrity program. We're a natural resource program. So I guess that's something to keep in mind. I can't tell what the weightings are. I can't read them. But
God, I can touch on that a little bit. Currently, it's 30, 30, 30 with AOP being 10. And there's a reason for that, in that when I was looking at all of our NAC data, and you
Yeah.
do a distribution of the data. It was bimodal, so you'd get this big peak around insignificant barrier or moderate barrier, and then you'd have an equally sized peak at severe. So out of 600 crossings, 25% of those were coming out as severe. And so the reason that I initially, and this is again a carryover from the upper Sopus work, but the reason that was so low was because that was not prioritizing enough. So to weight all the other ones a little bit more heavily, it brought in some of those other factors and significantly brought down that upper end peak. And so now you're getting, only 5 to 8% coming up as this critical priority. And in almost every case, they were severe aquatic barriers as well.
Right. They go hand in hand, right?
Yeah, exactly.
Yeah.
But so that was the reason why it's so low.
Yeah, the other thing that I should say, just to touch on these asterisks a little more, one of the modifications that I worked with Tim on to make to the scoring, the weighted scoring field, is if we are missing one of these fields, the weight of the field is then redistributed amongst the remaining valid data fields. And so, these weights really, they're just initial weights of the work that is coming out of the watershed and Tim's work with the highway superintendents in that area. But B, they're only valid for the sites that have all 4 parameters as an input.
And 2 examples of that is, like I said, the Cornell culverts model doesn't do large culverts or large structures. So more often than not, it's the flood flow capacity that's missing. But the geomorphic compatibility can also be missing in the examples like in NAC when you have no upstream channel. You've got a pond or something, and you're not able to get an active channel width. That kind of throws off the whole geomorphic score, and so you can lose geomorph that way as well.
Yeah, the goal was, a lot of the sites were kind of falling out. And if you assess a NAC site and there's missing data and it doesn't end up with a score, we want to make sure that point still ends up on a map. So, this is just an initial, and again, I'm open to changing it based on kind of the group's priorities. And it's definitely something that I'm happy to follow up with folks on if they're interested.
But Ben, if you just wanted to look at what might be a funding opportunity, you could just go to the aquatic passage box and just click specifically on severe barriers, insignificant barriers, or whatever, right?
Yep. Yeah. So, and again by town. So if we want to look at Marbletown, here are all the NACs severe barriers.
That's a good point, Andrew, whoever made that point.
Yeah, thanks, Andrew.
But then there you go. Most of them are red or orange, so you got to start clicking through to get to them.
So, and yeah, like Andrew was saying, you can do that for any of these. And everything updates, kind of everything's tied together too. So, yeah, again, the goal is just to make it really easy to use. So, the other thing that I wanted to ask and for folks just to think about is when you're trying to either identify a crossing with staff or for anybody that you're communicating with, if there are parameters for that crossing that would be helpful up here. I just kind of made a best judgment call on the NAC survey ID, the road, the inlet width, and the crossing type, but I can continue to build out this details table. For example, sometimes the material might be important, so we could add material type into this table. So if anybody sees something that is missing, definitely happy to make some adjustments. All right. Any last minute questions?
I have one question. I missed the intros, I think, because I was having a problem with my audio.
Sure.
Who are the other folks on the phone
All
or on
right,
the call?
let's see. We've got you guys at the Estro program. Justin Gates, the city of Kingston. Andrew Emmerich is Ulster County. Lou is town of Marbletown. There's a Kay Phillips. Don't immediately recognize that name. And we might have had somebody on the phone too. But all of the kind of focus area municipalities were invited. And what I'll do is I'll clean up the recording and I'll put it on the website and email the link out to everybody.
Okay, thanks.
All right, so I'll just leave it with that. If anybody wants to grab our contact information, and just a big thank you to the Estro program and New Pick for funding the project. And like I said, you know, if anybody has any feedback or any questions, feel free to get in touch. I'm around. So thank you everybody for joining.
All right.
Thanks, guys.
Thanks, guys.
All right,
Appreciate it.
thank you.
Bye.
Thanks.
Talk to you later.